Now let us understand the working of an electric motor. We have already discussed the components and their arrangement. Now, as the ends of brushes X and Y are attached to the ends of a battery. So, when we plug the key, what will be the direction of electric current in the circuit? Students, refer to figure and try to understand. Current will pass from positive terminal of the battery. So first of all, where it will go? It will go to the X brush. From that, it will go to the rectangular coil, which means the direction will be from X to A. It is shown in the figure. Then A to B, then it will be B to C, C to D, and then again from D it will come back to brush Y. Here you need to recall that brushes X and Y are conducting and stationary, right? Now from Y, where it will come? To the negative terminal of the battery. So this is the direction of an electric current, how it will flow. Now when I say that the current flows in the rectangular coil, now remember this, the direction of an electric current in the coil will be from A to B, B to C, and C to D. Here you need to remember that the direction of electric current in AB and in CD will be opposite direction. Okay, you see, because it is a rectangular coil, so from A to B, B to C, and then C to D, both will be different, opposite, right? So please remember that inside AB and CD, it will be opposite direction of current. Okay, now we need to apply Fleming's left hand rule here, which we have studied in a previous session. So according to this, if we stretch the left hand, then the forefinger points in the direction of the magnetic field, and then middle finger shows the direction of the current, and then thumb, that will be direction of motion or the force which is acting on the conductor. So if we apply this Fleming's left hand rule for electric motor, then here we have two poles of magnet and the rectangular coil. In the beginning only, we have placed the rectangular coil and the two poles such that the direction of magnetic field and the rectangular are perpendicular to each other. So when we apply Fleming's left hand rule, then the direction of force on a current carrying conductor in a magnetic field we can understand, because we have the direction of current, right? We have the direction of magnetic field, so by using this two, they are perpendicular, so by using this two we can come to know the direction of force which is acting on the conductor. Now when we apply this Fleming's left hand rule, then what do we observe? Please note this in your mind and learn it well. What do we observe? We observe that applying left hand's rule, arm AB, side AB, push is downwards. The AB side will be pushed downwards, while the force acting on side CD pushes it upwards. Again, I am repeating, the force which is acting on side AB, that force is pushing it in downward direction. We know, students, that whenever magnet is placed in the it will produce a displacement. So here also displacement will be what? That is due to force, because when there is force then only displacement will be there. So now we are talking about force. So the force which is acting on side AB, that is making the side AB to push in downward direction. The force which is acting on side CD, that is pushing it in the upward direction. Now, if AB is pushed downwards, CD is pushed upwards, then what will happen? As a result, we know that the axle is placed under the split ring, right? And it is free. It is not fixed. Again, I am reminding you, brushes X and Y are fixed. The axle is free. It can rotate. So now this rectangular coil ABCD is attached with the split ring. What will happen? AB is pushed downwards, CD is pushed upwards. As a result, the axle will rotate. And axle is rotating, and it will rotate in anti-clockwise direction. Okay, in which direction it will rotate? It will rotate anti-clockwise. And there will be half rotation. It will not fully rotate. Why, students? Because AB is pushed downwards, CD is pushed upwards. So it will have only half rotation. Now, imagine that there is a rotation, half rotation. Then what will happen? What will be the changes in this circuit? Try to understand. Very easy. If there is half rotation, what will happen? Q will be in place of P and P will be in place of Q, right? Which means the brushes are fixed. As a result, P and Q's position will be changed, because that axle, that is not fixed, no? So it will have half rotation and Q will be in place of P, which means now with brush X, Q and is there. What about Y brush? With Y brush, now there is P point. Okay, when? After half rotation. Now, think for rectangular coil. What will be changes in the rectangular coil? Now the rectangular coil will be DCBA. In the place of AB, DC will come. In the place of CD, AB will come. Okay? And then the direction of current will also be changed. Here in this figure, you can clearly see how there is a half rotation. Is it clear? You can see that each time when there is a half rotation, the direction of current keeps changing. The blue arrow shows the direction of current. So every time when there is a half rotation, direction keeps on changing. Okay, so when we have DCBA path, so current will move from which point? From D, then to C, C to B, and then B to A. This way, there will be changed in the electric current's direction. Now, who is responsible that the direction of current or direction of flow of current is reversed? Who is responsible for it? It is commutator. Okay, so here is the definition of commutator which you need to remember. A device that reverses the direction of flow of current through a circuit is called a commutator. Please remember, a device by which we can reverse the direction of current. Before the rotation it was different, after the rotation it is different. So A device that reverses the direction of flow of current through a circuit is called a commutator. Can you tell me, for electric motor, what is a commutator? I'm sure that by now you all know that in electric motor the split ring acts as a commutator. Okay? When I showed you this figure before, I said you that commutator and split rings, they both are same only. So split rings acts as a commutator in electric motor. And what it is? It is the device that reverses the direction of flow of current in a circuit. After the rotation, recall that first AB side was pushed downwards. So here now what will happen after the rotation? AB will be pushed upwards. Earlier CD was pushed upwards, and now what will happen? CD will be pushed downwards. Why is it happening? Because the direction of electric current, that is now opposite, that is changed. Okay, so as a result, AB will be pushed up and CD will be pushed downwards when after the rotation. Okay, therefore the coil and the axle rotate half a turn more in the same direction. Again it will take turn, right? It will get reversed. And this way the reversing of the current will be repeated. You see, every time it will be repeated, and it is repeated at each half rotation. Once the coil is reversed, the direction of the current will be reversed, right? So every time the current will be reversed when the coil will be rotated for half rotation, and as a result we will have continuous rotation of the coil and axle. Remember, axle is not fixed, it is rotating, so there will be continuous rotation of coil and axle both. The commercial motor use an electromagnet in place of permanent magnet. We have learnt about electromagnet previously. What it is? A strong magnetic field produced inside a solenoid can be used to magnetize a piece of magnetic material. And which is that material? Soft iron. And when it is placed inside the coil, the magnet is known as electromagnet. So instead of permanent magnet, the commercial motor use an electromagnet. Then large number of turns of the conducting wire in the current carrying coil. There should be large number of turns of the wire. And a soft iron core on which the coil is wound. There should be iron core on which the coil wire can be wound. The soft iron core on which the coil is wound plus the coils is called an armature. A-R-M-A-T-U-R-E, armature. What is armature? It is a rotating coil which enhances the power of motor. Why? Because there is a soft iron core on which the coil is wound and the coil. So that enhances the power of the motor, and this is called armature. So in general, you can remember it as that an armature is the rotating coil which carry the current. And how is the structure? The structure is the soft iron core and the coil. So this is all about the working of electric motor.